section 9.7 is on factoring special products. The first one is called the difference of squares. This is a binomial, which means it has two terms, and the difference means they are subtracted, and both of the numbers are perfect squares. It factors into a plus b and a minus b. You need to make sure that you can recognize your perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. 12 squared, 13 squared. Recognize numbers like 30 would be 900, 40 would be 1600. So you just recognize that those numbers are perfect squares. You can make a list and study them. Let's look at some examples. X squared minus 25. It breaks into the sum and difference of the square roots of these numbers. The square root is x, the square root is 5. Breaks into x plus 5 and x minus 5. It doesn't matter which order you put those in. Let's take n squared minus 100. That would break into n plus 10 and n minus 10. Notice when you multiply by FOIL, when you check it, n squared minus 10n plus 10n. They cancel each other out to 0, minus 100. What happens in FOIL when you're remultiplying? The outers and inners cancel each other out. So you're just left with the first, which is n squared, the last, which is minus or negative 100. 4y squared minus 25. Recognize the 4 is a square, the y is a square. The square root of that is 2y. The square root of that is 5. So it breaks 2y minus 5. We'll put the minus first. 2y plus 5. And again, the order does not matter. 2y plus or 2y minus first. Also, when you see the word factor, it means completely. One of the first things you need to look for I'll take this problem. Look for a GCF. You recognize that this is a difference and it's a binomial. 2 is not a perfect square, neither is 200. But if I take out the GCF of 2, I'll be left with y squared minus 100. That then is the difference of squares. Now remember, 2 is part of the answer, so don't just drop it off. The square root is y, square root is 10. A y plus 10 and a y minus 10. That's the way that one would factor. Let's look at another special case. Let's take x to the 4th minus 1. Remember the word completely when we factor. Also, recognize that any even power is a perfect square. X to the 4th is x squared squared. X to the 6th is x cubed squared. X to the 14th would be x to the 7th squared. Remember, that's your PM rule, we call it. When you raise it to a power, you multiply, that's x to the 14th. So the square root of this is x squared. The square root of this is 1. So this factors into x squared plus 1 and x squared minus 1. That, again, is what we call the difference of squares. This one is repeated. Remember, you can't just drop it out. This then factors into square root is x, square root is 1. X plus 1, x minus 1. That would be the final answer. Let's say we have x to the 10th minus 4. Again, you recognize it because that's an even power, so that's a perfect square. 4 is a perfect square, and it's a binomial. There's no middle term in there, no b term. This is x to the 5th, that's the square root, this is 2. So it factors x to the 5th minus 2, x to the 5th plus 2. Just double check that's not a perfect square, that's an odd number. So that is your final answer. Just make sure that you factor completely.